Question 12 starts off in a similar vein to question 11, but it extends it a little bit, and it is quite a nasty question. So if you've come away with anything from this, you've done very well. In the first part, part A, we are told that a log to the base 2 of x equals a, and we're asked to find in terms of a the simplest form for log to the base 2 of 16x. So very much like the previous question, we're just going to use the log rule that log ab is the same as a log a plus log b to rewrite this as log to the base 2 of 16 plus log to the base 2 of x. And again then here, because we've got a base 2, we want to try and express 16 in base 2. So we can express this as log to the base 2 to the power 4 plus log to the base 2 of x. Use the log law that log xy is the same as y log x to rewrite the first expression as 4 log to the base 2 of 2 plus log to the base 2 of x. From the previous slide, you'll remember that anything, if we have log to the base a times a for any number, that will always equal 1. So this is going to be 4 times 1, which is equal to 4, plus log to the base 2 of x, which we've told up here is equal to a. So this first part is going to be 4 plus a. In the second part of the question, again, essentially just using log laws here. So we can express this as log to the base 2 of x to the power 4 minus log to the base 2 of 2. Again, bring the exponent down. This is going to be 4 log to the base 2 of x minus log to the base 2 of 2. Again, log to the base 2 of x equals a. We're told that up here. So this is going to be 4a. And indeed, again, this is just going to equal to 1. So part B is going to be 4a minus 1. Part C is where the fun really starts. We are told to solve using the answers to part A and B, which we found earlier or otherwise, the solution to this expression here. And the kicker here is that we need to give our answer in exact surd form, which is just that extra layer of challenge for the final question of the paper. So let's just take what we know from part A and B. So this first part here is 4 plus A. And the second part here, then substituting in from part B, is going to be 4a minus 1. Careful to include the brackets around it. And we know that that equals a half. So first things first, then let's just tidy this up a little bit. So we're going to end up with 4 plus a minus 4a plus 1 equals a half. So we can just tidy that up a little bit, and we are going to get negative 3. If we take that over the other side, that's going to give us 3a equals 9 over 2. So from that we can elucidate that a is going to equal to 9 over 6, which is going to be 3 over 2. So there's a value of a, but at the moment that doesn't seem to reconcile with what the question's asking us to do, which is to give an answer in exact surd form. We are told in the question that a log to the base 2 of x equals a. So if we take this and substitute it back in here, instead of having a is equal to 3 over 2, we can set a log to the base 2 of x is equal to 3 over 2. So what we want to do now then is put both sides as exponents of 2. So that will cancel out and then leave us, excuse me, x is equal to 2 to the power 3 over 2. Now, in order to get it in surd form, we need to interpret this using index laws. So this is going to be the same as the square root of 2 cubed. Now, 2 cubed, we know, is 8. So that is going to be the square root of 8. which we can express as the square root of 4 times 2, which is the same as the square root of 4 times the square root of 2. The square root of 4 is 2. So our solution is going to be x equals 2 root 2.